Hi, we are here on behalf of Team 15 for the programming, here to explain the programming language called Zenith. My name is Arvind Anand.
I'm Rahul Manoj.
Hi, I'm Harshit Singh.
I'm Akash. So we can start with the presentation.
Yeah, so this is our language specifications. Our language, as we said before, is called Zenith. Its file extension is .zth. It's an imperative programming language. And the tools we mainly use was Antler, PyCharm, and VS Code.
Now we'll go on to the features of our language. So as the project had defined, we have all of the basic features. That would be the data types, the identifiers and numbers, the arithmetic operators, assignment operator, Boolean operators, ternary operators, as well as comments and print statements. Also, we have both the loops and the if conditions as well. We also have some additional features like typecasting and dynamic declaration, which just basically means that on declaration, you can also give an expression value with the assignment operator as well. So that concludes the feature. We will talk about the features in detail when we talk about the grammar and the explanations, the sample runs. Now we'll go to the grammar.
Yeah, so I can start with the grammar. So our grammar has the program and the blocks. So blocks are nothing but statements enclosed in curly braces, and we also have the atomic block, which has the command and declarations. So declarations are like where the variables are defined with the types, and our grammar supports integer, boolean, string, float, double, and also ternary expressions as well as boolean expressions. And to add on, we also have the empty declarations. Our grammar supports empty declarations. And for the commands, we have the if expression, while, for enhanced, for loop, and print and assignment expressions. So let's move on to the ternary expression, which will be explained by Arvind.
I think it's down.
What's down?
Yeah, ternary is down. Yeah, so ternary expression it's a basic rudimentary ternary expression. You have a condition, an expression block, which can be an expression. We can also use a Boolean or any valid string as the control case. I think we'll move on to the assignments and expressions, which should be taken by Rahul.
Yeah, so in our expressions, we have the assignment expression, which basically has the identifier, the assignment operator, which matches against the numerical expressions, the Boolean expression, and the ternary expressions. Now, when it comes to the normal expressions, we have the numerical expression as well as the Boolean expression, and both of these have precedence included into it. So as you can see here, we have the for the and, or, an equal to, or for the logical greater than, less than, equal to operators, as well as for the brackets. So there was some precedence requirements over here. Similarly, also for the arithmetic expressions, as was done earlier in the course as well, we have precedence included here as well. For the conditions and looping, I think Harshit can take over.
Yeah. So I think Arvind, do you want to take over the if expressions?
Yeah, so our condition block is basically a bracket, a Boolean expression, and a close bracket. And we support if, else if, and else expressions. So our if block is basically an if, a condition expression, and then we can have how many ever number of else if expressions we like, and optionally you can have an else expression. And our else if expression is just bog standard the same, else if condition expression, and obviously the else expression is pretty much the same. We have tweaked our if condition to work with our with Python, since our grammar is more similar to C kind of grammar, which we will explain when we talk about it in the listener. I think loopings will be taken care of by Harshit.
Yeah. So we have a standard while expression. So it will be the word while followed by a conditional expression that will evaluate a true or false, and a block that will be executed. We have the for enhanced. So it will be like for the variable identifier I or anything in range, and we have range values. So range values can be expressed in terms of variable identifiers or in terms of digits. So our language supports both. we have the traditional C for loop. So for I equal to digits and Boolean expression and the variable change part, how we have standard loops in C. So the variable change part, we have defined increment expression, decrement expressions, and variable identifier assignment operator. So I equal to 2 or something like that. So decrement expressions are minus minus, increment expressions are plus plus, pretty standard C stuff. I think Arvind will explain the rest of the grammar. So
Yeah, so the rest of it is just mainly just our print statement. Our language allows you to just use one parameter for print, or you can chain it and use how many ever parameters you want. We don't impose any limit. Since we used Antler, we have basically followed its syntax, in which the axioms are defined in capital bold case, and then the lower cases are for our other operators. And we have a comment block, which basically can take any value in it, and we remove it from our listener when we have it. And I think yeah, I think that is pretty much wraps up grammar. We will probably move to the listener, where we want to kind of show some of the specific changes we did. One main change which we alluded earlier was changing our open and close brackets to indentation. We do this by calling two of our functions, indent op and indent op condition. Basically, the code has a stack which we use to maintain the indentation, and every time an indentation increases, we add to the stack. And so as long as we can count the length of the stack, we know at what depth the indentation is. And this works surprisingly well for all our conditions and loops. There is one more thing we have done with our listener, which we wanted to show. And I think Harshit would go over that part.
yeah. So in our listener file, what we're doing is we are adding everything to an intermediate output. So if we Rahul, can you go to the top? I'll just explain the basics of it. So what we do is everything comes here to process, and we add to the intermediate output whatever code we want the Python to process. So this is how we're doing it. So, and you can see some of the program blocks are empty. So what's happening is the parent is passing whatever info it is getting to the child, and the child is processing it. So otherwise the parent will also process it and the child will also process it. So we don't want duplicate statements inside our intermediate code. So we just pass from the parent, the child takes care of it. One of the peculiar things, one of the features from our language is the type casting that we have introduced. So in integer assignment, so if we have declared any identifier as an integer, so while evaluating the expression associated to it, if the value becomes a float or a double, we don't allow it to be, so we make it integer. So as you can see here, we are doing int value, and we specifically make it int. So Python typecasts it for us. So we have that type safety for us.
And if we could just show the runtime just for just to show you how we handle our runtime. So our runtime gets the code from the listener, and as we alluded before, the indentation, we add the indentation here, we get the stack, and then every time we encounter a curly braces, we add an indent, and every time we encounter the closing braces, we remove the indent. And
just to give some specifics here, what we do is we add the brackets to the intermediate code based on the stack length. Since our runtime is using Python, we need to basically convert those brackets into indentation. That is the reason why we have this bracket stack thing going on.
Yeah, and if we just go down, I believe, yeah, so if there is you notice there's a combined code and there's a individual code. So the reason why we have these two types is because there are instances where we would want to evaluate just a combined code of block. Basically, like a good statement would be like an if-else statement. You don't want to evaluate an else statement without having context of an if statement, because depending on the condition, only one would get executed. If you were to execute line by line, it would completely break the logic of the program. So we basically combine all our codes which need prior knowledge of the lines, and then we exec them in one block. And for everything which we don't need, which we can do it line by line, like say like print statements or just like normal evaluations, which can be just done in a single line, we just use the else condition, and we let Python evaluate it. And I think we will now move to a couple of examples. I believe
I'll start with the declarations example. So our language supports assigning values to the variables while declaring them. So as you can see, int a equal to 5 and int b, and this is the comment. We have used hashtag for the comment. So all integers will get a default value of 0. All booleans so similarly for boolean, if we have not defined it explicitly, it will get a default value of true. We have the string declaration, string d equal to Zenith grammar. We have float e equal to 3.55, and for floats we have kept the
precision.
Precision, sorry, I'm sorry, I was blanking out. So for the precision, we have kept as 4, and for double, we have not kept any such precision. So after running the code, that we can see here is that the a equal to 5 and b equal to 0, c equal to true, d equal to Zenith grammar, e becomes 3.559, it maintains the precision, and the double is not changed. So this is for the declarations.
So we'll move on to the expressions now.
Yeah, just to add to this, the float, we have set the precision as 3 digits after the decimal point. We could set it for whatever, but we wanted to set it for this since this is our language, right?
Yeah,
I think.
Yeah, move on to expressions.
So for expressions, so first line integer a not defining, so it will get a default value of 0. Boolean b will get a default value of true. And then we have assigned an expression to it. So b becomes true, or b and true. So this will get evaluated. And finally, we get the value as false for b. And for similarly for a, we do the evaluation of this expression. So we have operator precedence in place. And after execution, we get the value of -23, as you can see in the terminal here. And we do a print statement, print a comma b. So our print statement support printing variables as well as the string. So this is the variable. So you can say -23 comma false.
I think we'll go to ternary next.
Yeah. Yeah, so this is how the declarations are supporting the ternary expressions as well. So I'm giving integer a equal to this, the 2 greater than 1 gets evaluated, so it is false. So a 2 is greater than 1, so it is true, so it gets the value 5. And string 100 is not greater than 231, so it gets the value as denied. So as you can see in the terminal, so ternary is evaluated and the value is assigned to the variable.
Yeah. We can move on to which one's next?
While,
right? Yeah, test while.
yeah.
So we start a while loop here, a equal to 10, b equal to 1. So we run the while loop till a is greater than 0. And so we add b 1 to b, and we make the a as a minus 1. So at the end, a becomes 0 and b becomes 11. So while loop is working.
Yeah, it's a standard code.
While, yeah.
Next, we'll move on to the for loop.
Yeah.
Yeah. So for for loop, it's a standard according to our grammar. We've just put like what is that? We're basically checking to loop the C for 9 times. And if you checked hello, it would have looped it exactly 9 times. And we convert our for loop to Python syntax in our Lexer, just for it, since this is a normal fall. If you look at for enhanced, this is more in range with Python, and our grammar does support this. So pretty self-explanatory. You can just look at the code.
The prime number executed.
Yeah, it's basically checking if it's a prime number or not. So that's fine. I think we'd move on to the if and like any control nested if. Yeah.
There you go. Yeah, so I can explain the if part. So as you can see, there's a complicated structure of ifs over here, completely nested within each other. And in this particular situation, I think we have A is equal to 217 or something. So it doesn't actually go inside this particular case. It just comes straight to the else case and prints C equal to 119. Now, if I was to simply change this as A plus 4 is it? I think, no, we don't need this. And just comment it out. And you'll see that C becomes 10 and A becomes 51. And that happens in places here because it's going inside this if condition. So that basically explains how the if is working. I think that explains all of the initial expressions. We also additionally have the factorial as well as the prime number one as well. Maybe I can run that and just show the outputs as well. So you can see how for I is 8, it prints the output of 40320. So it's computing the while, using the while to compute the factorial. And similarly also for prime numbers. It's the exact same code as the other one, but with a different follow. And this is as well as computing for the value of 18. It shows that there are 4 meets of the divisible numbers. So it's basically not a prime. So that concludes.
I think since we finished this and we do have a little bit of time, maybe we could just show the pass tree for some of these, just like
we can
go
show
through
the
them.
correct. So
this is our grammar. This is our grammar.
Yeah. This is the structure of our implementation. So the parse tree is what we are going to show now.
Yes, so this is a factorial one. It's pretty simple. Yeah, prime number is quite big. Some of these are really big, which we couldn't include. Yeah.
Couldn't include the if one because it was way too long.
Yeah. So yeah, we could not include the nested if it was bigger than the screen.
Yeah, this is the intermediate code implement being printed out. So parse tree will be very big.
All right. I think that concludes our language. Thank you for listening. Yep.
Yeah. Thank you.
Thank you.